Okay, our last solution, using the trapezoid rule. Still have our same function, same integral, and there on the integral sign from 0 to 2 is your limits of integration and the interval which we're using on the x-axis. We're going to use 4 trapezoids, and this is what our picture still looks like. I want the area under that curve. Our delta x is important, so we'll find our delta x. So the endpoints of the interval 2 to 0 and number of rectangles is 4, so our delta x is still 1/2. We need to know our endpoints. We're using every endpoint that divides the curve up in intervals or pieces of a width of 1/2. So our endpoints are, we start with the initial one, so I'm going to have f of 0, and just add the delta x to that, f of 1/2, f of 1, f of 3/2, and your final endpoint is f of 2. And here's our picture. So our trapezoids are going to look like this. And notice how that approximates the curve pretty well. Okay. For the formula, the area is going to be delta x divided by 2 of every endpoint and double each endpoint inside the interval here. And 1 times the final endpoint, which is 2. Alright, our delta x is 1/2 divided by 2. F of 0 is 1. 2 times f of 1/2 is 5/4. 2 times f of 1 is 2. 2 times f of 3/2 is 13/4. Plus f of 2, which is 5. So 1/2 divided by 1/2 is 1/4. And 1 plus 10/4 plus 4 plus 26/4 plus 5.